Assalamualaikum. Welcome all. I assume that you are waiting video tutorial for regression. So that's why I'm making this one. Regression, or especially linear regression, I'm going to talk about. We'll do a live example, so it will be more clear to you. So regression for a given data, x and y data, you are trying to fit a model, okay, and that model is supposed linear. So linear model has two coefficients, a0 intercept and slope. So when we are trying to fit a model y equals a0 plus a1x for a given data set x and y, our job is to find the model coefficient a0 and a1, and we will apply the least square method. Least square method is basically you find the error between the y data and the y model. Y model is this, you can see, and y model is a0 minus a1x. So you find the error between them and square it. Square, why we need to square? Because we may get positive error and negative error, so that you can accommodate both of them. When I square it, the effect of both negative error and positive error both will stay, and then you square it and try to minimize the square. So minimizing the sum of the error square, SR. Okay, this one is the objective function to minimize with respect to what? What is the variable here? A0 and A1, they are the variable. So if we apply the calculus you learned in earlier courses, in order to minimize the function SR, here you differentiate with respect to variables A0 and A1, and here it is, you differentiate with respect to A0 and A1, and for maxima and minima we are looking for minima of SR. Okay, so for minima also it is like this, isn't it? The slope is 0. Slope is 0 means it should be equated to 0, and once you equate this to 0 and rearrange this, you will get this equation 2 by 2. We have two unknown, a0 and a1, and we get two equations, summation of x here, summation of x square, and in matrix form it takes this beautiful form. So now we can solve, we are applying the regression method, this square method, and we can solve this by many methods. Okay, I will take the example and explain to you. So this is a0 and a1, this is 2 by 2 matrix which can be solved to get exactly explicit equation in terms of a1 and a2. Okay, and once you get this a0 and a1, also you are interested to see the error, quantification of error. So how to quantify the error? One of them is SR, which is y model error square, so which gives you the deviation of y data with respect to the y predicted or y model. Okay, and we have ST, which is the deviation of y data, you can see y around the mean of y itself. This is ST, and you know that we are interested to know R square. So coefficient of determination R square is ST minus SR divided by ST. So we also calculate R square for a given fit. Okay, so remember this ST and SR we will apply in Excel and MATLAB, and remember this equation for R square, ST minus SR divided by ST. Okay, so basically this is the equations we will solve. Equation for R square. So right away I will come to the equation to solve. We have, and this is from your book 14.5 xy data is given to you, and you are asked to fit a linear model, linear equation, and get a0 and a1 and r square. Okay, the easiest way, we have built-in function in Excel to find, give you the using trend line. Okay, so trend line, just plot it x and y, and then I know all of you know this. So is this way is add trend line, and you can see we have many options: linear, logarithm, polynomial, power, and then you can, this is linear, display r square, display equation and display r square. So in this way you get the equation and r square right away. So the slope is 0.359 and so on. But now this is a built-in and black box for us, so we want to apply our numerical method techniques which we have learned. So one of the way we can do, just so the equations are this: a1 and a0, we have exact equation also. So this you can do by calculating x in Excel, x. So what we need xy. So xy is like this. So x times y, okay, and then we need sum. So we can get the sum of all sum of xi. Okay, we also need sum of x square in the equation. And I have applied sum here, so I can just drag this to get the sum of x square. Again, what I need sum of x, y. Okay, so also I need sum of x. This one also I apply sum of y. Okay, and then I need sum of xy as well. Xy, okay, I have it. So now if I apply the equation, this equation, I can get the a1, the slope. A1 is n. How many data point I have? You can count it. Just use the count function in Excel. 10. We have 10. So 10 times x, sum of xy. Sum of xy is this, minus sum of x times sum of y. So sum of x is this times sum of y. Okay. Then what we have, n times sum of x square. So n is 10, sum of x square, this is minus sum of x square. Sum of x and square. Okay, so I'm expecting this value to be 0.359. I hope I got it. Yes, so this is what I got it using Trendline also, you can see here, and this is what I got it from from applying the equation. Okay, and the a0, which is the intercept, what the equation for that? Y mean minus a1 x mean. So mean of y, mean of, okay, let's apply equation, equal y minus a1 times mean of x. I'm sorry, this is not mean in MATLAB, but in Excel it is average. So a1 is 4.88, so this is the same. So one thing is, this is Excel. Okay, now we can find r square. Okay. R square depends on ST and SR. ST, if you remember, ST is deviation between ST is y minus, here we can write ST, which is y minus average of y. And then a square of this. Okay, and then your ST is basically sum of those. So this is ST basically. Here it's y minus mean y square. Okay, and same way we can calculate the error square, which is SR. Error square, you can say y, this is y minus y model. So y model is basically 0.3591 times x. Then this is also, it will be minus 4.8881. So this is error, and then I am squaring it, so this is error square. Okay, and this is and I need SR, so SR will be sum of this, sum of, so this is basically SR. These are SR, and these are ST. Now R square is basically ST minus SR divided by ST. Let me check. R square is st minus sr divided by st. So now st minus sr, so is something wrong? Let me check. Okay, let me calculate st and sr again. So st is basically sum of y minus mean y square. So it's coming from here up to here. Okay, this is x and y. This is sum. So st value is 54.1. sr, which is sum of error square, y model. This is y model minus y. So this is coming up to here. So sr and st is this. Then r square, if this is r square, then st minus sr divided by st, and here and divided by st, and we got 0.8, same as Excel here. So this is in Excel. Video is too long now, so I will make the one more video for MATLAB. Okay, so I hope this is helpful. Thank you.